So just as an example, this first one, we want to know this arc. This is the which arc? Major arc, right? 315 degrees. How do we work out the arc length? Please, not all at once.
You find the little perimeter of the circle and then multiply that by 315 over 360.
Okay, so we have a fraction of a circle. So we have the fraction is 315 degrees out of 360 degrees. And that fraction of the entire circumference of the circle, well, the circumference is 2 times pi times r, which is 11. Right. And you can now tell me the answer to that. What? 30.2. 30.2. Everyone just confirm.
60.5.
Right, so that's just replicating what we did last week. This one, same idea. This one would be quite easy though, because we could do it as 270 out of 360, but what is that as a simplified fraction? 3/4, so you could treat it like that. So 270 out of 360 times 2 times pi times 13, or this bit we could simplify to 3/4 times 2 times pi times 13. Okay. Okay, that should just be a recap of what we did. Now the next two introduce you to something a bit different. What do you notice? The angle is 3 pi over 2. So when you see this, you can see that this means the angle is not measured in degrees anymore. It's measured in a different measurement called radians. And you might be thinking, well, why do you want to do it? Well, it's only like, well, you can measure this table in centimetres, but you can also measure it in inches. It's just a different way of measuring something, yeah? An inch is longer than a centimetre. So there are less inches in a certain distance than there are centimetres. And it's the same thing. Now, radians are a different measure for an angle. So 1 radian and 1 degree are not the same angle, right? So I did put something up for you. Here's my mirror. So this here tells you what a radian is, and it will give you a good idea why it's called a radian. 1 radian is about 57.2958 degrees. There was a bit of an interaction, so you can see here. This is a radian, and they show you how it was made, and it's kind of more mathematical. Click there, look, there's the radius, goes all the way around, and you wrap it around the circle. Right? See that again? So that distance, there is equal to the radius, and whatever the angle is, that's 1 radian. Okay? Right. Radians and degrees. 1, 2, 3, 3 and a bit. So it works out there are pi radians is 180 degrees. It's quite nice and simple, right? So how many radians in an entire circle? 2 pi. 360 degrees is 2 pi. And really, that's all we kind of need to know. Everything else we can work out. Alright? And that, don't you think that's quite interesting about the whole pi and circles and the angles of 2 pi angles, and there's 2 pi times the radius tells you the circumference, all those things, you know. So we're using kind of this information. 30 degrees is pi over 6. Why is that? Okay. It's a sixth of 180, yeah. Simple as that. 45 degrees is a quarter of 180. So it's a quarter of pi. 60 and so on. So we've got here, the thing about radians in exact form, well, we're not always going to be able to give every single angle, are we, as nicely as this. So radians don't work for it. Like we tend to have 23.2 degrees, don't we? Well, we can do the same with radians, but there are certain ones where we can write in terms of pi. Does that make sense? Now, this is where it can then be pretty good. It can be pretty good for solving a problem like this. Because actually, nothing really changes. So how do I work out the arc length of this? Well, it's 3 pi over 2 out of, not 360 this time, but 2 pi. Alright, how do I redo that though? How do I write a fraction divided by a number properly? Basic maths that you did in L3. So for instance, if I said to you do a half divided by 3, it's a sixth. Because you do 1 over 2, you don't divide it, you actually multiply the denominator, yeah? So could I do the same thing here? So this actually becomes 3 pi over 4 pi. Yeah? So that bit comes there. And why is that nice? Well, I can then, for instance, we've got pi times the diameter, or 2 pi r. I'll keep it consistent. So we're always doing the same thing. So we've got 2 times pi times r is 16. Now those pi's cancel each other out. So we're left with 3 times 2 times 16 over 4. Well, actually, we can start doing some other cancelling. The 4 with the 16 makes a 4. So now I've only got 3 times 2 times pi times 4, which is
75.3.
no, I don't want it like that. I want it in terms of pi. You don't need to use our calculator. 24 pi. Yeah. So when we deal in radians, we would tend to give our answer in terms of pi. Now it might be what we said there, but we've got 24 pi feet, and we can do all of that with no calculator. So I was saying we can kind of do it without a calculator. How do you feel about that one? Working in radians, not particularly any more difficult, right? Same thing. Just knowing that there are 2 pi radians in a circle rather than 360 degrees. Right, should we you have a look at the other one then? So what do we write? Pi over 6, but divided by 2 pi, so that makes it pi over 12 pi times 2 times pi times 13. Remember, this is exactly the same, but instead of having 2 pi, we'd have pi r squared if we were doing the area, which might be even better. What do we do now? What cancels? So this pi with this pi, what gets put on top? A 1, good. The 12 can cancel with the 2, so I've got 6 and a 1. So I'm now left with 1/6 times pi times 30, which is 13 pi over 6. We don't do anything more than that. Inches. Why am I not going to do anything 13 over 6? Why have I left it like that?
Does it have anything to do with like giving more working days, so we express it in that way?
Do it in terms of pi, but what about the 13 over 6? Yeah, can't be simplified. If I did the actual division, I'd end up with a decimal. What is there any point in having a decimal that you've rounded and then a pi? No. Right? If you're making a choice to have a rounded decimal, you include the pi in that and round the whole lot. All right. So if you're not going to do that with the fraction, well, if you're going to keep it in terms of pi, then the fraction should be a simplified fraction as much as possible. How do you feel about that? Some faces that just look like they're horrified, don't want to be here. You're going to clean my paper up after you wipe your head all over. Thank you. All right.
So, Mr. Fox.
Yes.
So if it was 12 pi over 6, that would just make it be 2 pi.
2 pi, yeah. Yeah, exactly. All right. So over to you. These ones don't have diagrams, that's all. We've got a couple in angles to practice your degrees, sorry, in degrees to practice your degrees. Got a couple in radians. Well, what I'm not asking you to do at the moment is actually convert these into degrees. That's kind of another thing. We don't need to worry about that. I just wanted to show you that we could do this in our 2 different ways. I would suggest there's no space here to write these out. Doing those in the book, drawing a little diagram, set it up.
And then looking at question 9, when it says do not round, does that mean express in terms of pi?
Yeah, give it its exact form. Yeah.
So something pi.
Well, no, yes, these ones, even if they're in degrees, you can do that. Let me just think. Yeah. Where it says do not round, it does mean give it exact form. Yeah. The other ones, actually, although I've been telling you, it does say in the question round to the nearest tenth. So those ones we could round, but. Right, I'm recording. Let's do an area one. So it does say round your answers to the nearest tenth, but we'll do what we do. All right. So when we're working out an area, it's the same principle. What fraction of this entire circle have we got? So we've got 60 degrees out of, well, because it's degrees, it must be out of 360. Okay. Multiplied, well, the area of an entire circle is pi r squared, right? You have to remember that's the area of a circle. So the arc length is a fraction of 2 pi r because that's the circumference. So this time we're using area. So we just need times pi times r squared is 10 squared. What mistake do people make when either A, they're young and inexperienced, or B, they're in an exam and they are rushing?
They put 2 pi as well.
Can do that, yeah. I'm thinking even if they've written this correctly, there's a silly, say silly, but yeah, silly mistake. What's 10 squared? And what's it not? 20. Yeah. Just saying, yeah. If I was, my M1s will tell me that 10 squared is 20 until they stop and think because we have redone it. So we've got this. I can put the times 100 in. I've got the pi. What is 60 over 360 simplified? 1/6. So I've got 1/6 of that. Already done that simplifying. So now I've got straight into, it's just 100 pi over 6. Can that be simplified? Yeah, so I should have done the cancel, 350. So I can got 50 pi over 3. And because it says round your answers to the nearest tenth, if you work that out, you'll actually get it as 52.4 square inches. That's the simplified exact answer, which is what I like. If the question asks for that, that's what let's do. Alright, so that's one done in degrees. This one, should we do number 16? Because it's got some yucky numbers. Right, 17 pi over 12. So this time we've got 17 pi over 12 out of 2 pi, so that's going to be 24 pi times pi times 14 squared. Pi's cancel. So I've got 70 over 24 times pi times 14 squared. Can I just ask, is it okay to simplify the 24 and the 14 to make, like, divided by 2 and have 12 and 7? Can I do that? 12 and 7. So I do 7 squared. Looks dodgy, yeah. It looks dodgy because it is dodgy. No, you can't do that. Right. We could cut. There is a shared factor between 196 and 24, though, isn't there? Because there is a shared factor between 24 and 14. But it's not as simple as just doing it at 24 and 14. We do know there is a shared. What could we divide by? 4. So divide by 4, you get 6. What's 196 divided by 4? Pardon? 49? All good with that? Maybe? Follow? So now we've got 17 times 49. Times pi, so let's just do this bit. Any more simplifying happening at this stage? No, 6 doesn't go into 2 prime numbers there. Not pi, that's a square number, but prime number 5. What do we end up with? Which you might be uncomfortable with because it's a big number and you've just left it like that, but if it's exact, that's what we've got. If we turn that into a decimal, round to the nearest tenth, what do we get?
136.3.
Square yards. So there you go, that's using degrees and radians for area. like I was saying, this is a prime example actually of where it makes sense to do these bits, break it down, use your skills for factorising and cancelling things down, rather than just plug everything into a calculator.
On the test, are the values in my favorite? You just say yes.
Yeah, no, we'll be able to use it. Well, yes, we will, but what I will do is, I've already said, this is kind of more preparation for DP, and you will maybe, depending on what course you choose to take, SL or HL, have to do a non-calculated paper. Alright, so there is a chance that this is the kind of stuff you have to do without calculating. It's, you know, what's the hardest thing we've had to do there? You know? Just a bit of multiplication tables stuff. Alright. And it actually matches what we've just been doing, so don't feel that, oh, I'm just doing something different. Okay. If I were to ask you to sketch a sine curve, it goes up to what? Ladies, are you going to stay with me here? What does it go up to, a sine curve? If I just said sketch y equals sine of x. It goes up to 1 and down to, right, well, what are the important degrees? 0, 90, 180, 270, and 360. And you know that because it starts there, goes up there, it comes down, right? So you can sketch a curve. Right. Now I'm kind of thinking, well, what would it change if we did it in radians instead? Anything?
Yeah, but look,
Alright.
I mean,
But what should 180 be written as? Pi. What should 360 be written as? 2 pi. What does 90 get written as? Pi over 2. What does 270 be written as? 3/4 of 2 pi. So it's another half pi on top of pi, so 3.5 pi. 3 halves of pi, not 3.5. That's it. Done. So now this leads to another thing with radians, which is if I said to you, alright, solve, here's a check for your memory, solve sine of theta equals, what should we say, a half. No calculator needed. Remember the special triangles? Sine is opposite over hypotenuse. Opposite over hypotenuse, so theta is 30. But also, right, if I now said to you, look at the same diagram, what is sine of 60 without using a calculator? Root 3 over 2. Yeah? What if I said to you sine of, what would it be? Change 60, do you think, into radians? So, 180 degrees is pi radians. Yeah? 60 degrees is therefore pi over 3. Yeah? Radian. So if I said sine of pi over 3, what would that equal? Root 3 over 2. Now I'm going to get you to check that in your calculators. Alright? Do do sine of 60 degrees, pressing your degrees button, what do you get? If you won't get that, you'll get a decimal. 0.866. Okay? Right. Do root 3 over 2 for me, just to check. Give me the same thing. Now, without changing anything else, do sine of pi divided by 3 for me.
0.018.
Okay. You get the wrong answer, right? Why do you get the wrong answer?
Is this in like radians?
You need to be in radian mode. So switch your calculator into radian modes. You've got that DRG button probably.
Yeah. Oh.
Change it to radians, and now do sine of pi over 3. Radians. Do sine of pi over 3 in radian mode. Do you get 0.866? Yes. And it will need me to show you how to do the change. Let me know.
Wait, 8 degrees.